Polymers are macromolecules having high molecular weights and composed of smaller repeating units called monomers. The term polymer is derived from Greek roots. Poly means many and meros means part. Monomers are small and simple molecules and have a capacity of forming two chemical bonds with two other monomers.
Polymers are high molecular mass macromolecules, 10 raised to 3 to 10 raised to 7 U.
Classification of polymers. Polymers are classified in a number of ways on the basis of their source. Chemical structures, mode of polymerization, molecular forces, type of monomers, and biodegradability. Learn about classification based on source. Polymers are classified into three subclasses as given below. A. Natural polymers. Natural polymers are polymers that are obtained either from plants or animals and are named as plant polymers and animal polymers.
Classification based on source. Natural polymers. The polymers obtained from natural source are said to be natural polymers. They are further subdivided into two types. Plant polymers. These are obtained from plants. For example, plant polymer cotton is obtained from cotton plant. Flax plant produce linen, starch, cellulose,
protein.
Natural rubber of natural polymer which is manufactured from the latex obtained from bark of rubber trees. Animal polymers. These are derived from animal sources. For example, wool is obtained from hair of sheep.
Before the wool was not cut from the sheep, it was looking like this. After cutting that wool from the sheep, it looked like this.
Ideal for clothing like sweaters and coats. Sheep shearers use power shears, fibers. This grading is based on length, color, waviness, and fineness. The wool arrives at the factory in compressed bales. Workers untie them and feed the wool into the opening equipment, whose metal tooth rollers comb out and separate the fibers. From there, the fibers go into the blending room, where air currents mix different grades of wool fabric. A fully automated loom does it all. Watch in slow motion as it inserts one strand at a time of weave. The loom inserts wool fabrics undergo finishing to give them a particular appearance.
Synthetic polymers. Polymer which are prepared by man in laboratory by polymerization of one monomer or co-polymerization of two or more monomers. This synthetic polymer is prepared by man in the laboratory. So here you can see this man is preparing a polymer in the laboratory. Okay. So what he is doing, he is taking ethene, many ethene molecule, and when these are known as what, monomers. The ethene molecule is known as monomers. So all the bond is breaking, one pi bond is breaking, and all this monomer get joined with each other, and that is, it is undergoing the polymerization reaction, that and it form a very long chain known as polythene. So here polymer is formed by the polymerization of one more monomers. So here, can you see the animation here? These two monomer are joined together to form many monomer are joined together to form a very long chain known as polymer. Next, example of synthetic polymer. So you can see this is normal pan, and what we have done, we have coated it with the Teflon coating. The Teflon is a synthetic polymer. Nylon, polythene, Orlon, and this is all formaldehyde resin, terylene, polystyrene, and last is silicones. How are synthetic polymer classified? Synthetic polymers are classified based on fiber. See here, fiber is there. Okay, means it is very long thread like structure. And another is synthetic rubber, and last is plastic. Next topic, semi-synthetic polymer. This is the third topic. First we have studied the natural polymer, second we have studied synthetic polymer, now it is semi-synthetic polymer. In semi-synthetic polymer, which is also known as regenerated fibers, example, cellulose derivatives such as cellulose acetate rayon, viscose rayon, cellulose nitrate, cupra ammonium rayon. Semi-synthetic are used in the preparation of non-inflammable photographic film. Of this film is made up of what? Semi-synthetic polymer, that is that it is a inflammable, means it will not catch fire. Then it is used in cinema films and varnishes. So what is varnishes? Varnishes is a liquid mixture that form a very hard, shiny, protective film after drying. It is applied on the wood to protect its surface from moisture. So classification of polymer based on structure. So based on structure, you can see here this polymer is straight. All the monomer are joined in a linear fashion. Therefore, it is a linear polymer. Here you can see it is a branch polymer. In between there is a chain. So it is known as a branch chain polymer. Next is cross-link polymer. Between the two linear polymer, you can see this is one linear polymer, this is one linear polymer, this is linear polymer. In between that linear polymer, there is a one bonding in between. Therefore, this is known as what? Cross-link polymer.
Linear polymer. Monomer molecules are joined together in a linear arrangement. The resulting polymer is straight chain polymer.
So you can see here the monomers are joined together in a linear fashion. Therefore, it is known as what? Linear polymer. So this is the example of linear polymer. Example is PVC and HDPE. High density polythene.
Branched polymer. Monomer having three functional groups or already having side chains give rise to branched chain polymers.
There is a side chain which one monomer is joined with three another functional groups. So to have a branch chain, there should be a three functional group. 1, 2, 3. Three functional groups should be attached to form a branch chain polymer. So if there is a two functional group, it will form only straight chain. So to have a branch chain, minimum you require a three functional group to have a branch chain. So example is what? Low density polythene. This is the example of low density. What is the meaning of low density polythene? Low density polythene is such a polymer where you can squeeze it very easily, such like tomato sauce bottle or eardrop bottle, where you can squeeze very easily, and such type of polymer is known as what? Low density polythene. So next example. Next is cross-link polymer. The cross-link polymer are formed between the two linear polymers. This is one linear polymer. And this is another linear polymer. So these two linear polymer are joined together by some atom. So here the atom which is used is sulfur. So here the sulfur is attaching the two linear polymer and formed a what? A cross-linked polymer. Example is bakelite. Another example is melamine. So it is an unbreakable dish plate.
Addition polymerization. Addition polymerization is a process of formation of polymers by addition of monomers without loss of any small molecules.
Addition polymerization is the formation of polymer. So you can see here this is a polythene. The polythene is a polymer which are formed by addition of monomers. So ethene is a monomer. So there are many monomers. Monomers is ethene. So ethene. So when this ethene molecule undergoes polymerization, so here there is what? There is a breaking of bond here. Okay, when after breaking the bond, they joined with each other and form a very long chain structure which is known as polythene.
The repeating unit of an addition polymer has the same elemental composition as that of original monomer.
So here what is the repeating unit? Here the repeating unit is what? Ethene molecule. Here CH2-CH2 is repeated. So repeating unit of the addition polymer has the same elemental composition of the original monomer. This part is similar to that monomer which we have used here. So here ethene is used and the monomer and the repeating unit structure is almost same. So what is addition polymer? Whenever you add the monomer, there is no removal of any molecule. Only there is a breaking of bond and formation of bonds.
2. Condensation polymerization. The process of formation of polymers from polyfunctional monomers with the elimination of some small molecules such as water, hydrochloric acid, methanol, ammonia is called condensation polymerization.
So here these are the monomer. So what is the definition of the condensation polymer? The process of formation of polymer from the polyfunctional monomers. So here there is a two monomer. Okay, there is a two monomer. When these two monomers, when they combined, there is a loss of water between them. So there is a loss of water. One molecule suppose give H, another molecule give OH. So H and OH will remove the water molecule. So there is a removal of water molecule and there is a condensation take place. And this part is known as what? Condensation polymerization. Another example, this is the two monomer. If the two monomers, in between the two monomers, if there is a removal of any alcoholic group or HCl group. Here you can see small molecule water, HCl or any methanol, any alcohol, ammonia is removed, and these two monomer when they join together form a polymer, and this is also one example of condensation polymerization. So an example of the preparation of terylene. This is the example of condensation polymerization. To prepare a terylene, this is the type of polymer which is known as polyester. Why it is called as polyester? Because when the two molecules combine with each other, the functional group which is formed is the ester group. So many ester molecules are formed, therefore it is known as polyester. I have given one example of terylene. See, you have to prepare the terylene. The starting material which is used is ethylene glycol, OH-CH2-CH2-OH, and another molecule which is used is terephthalic acid, with the formula is COOH, benzene ring COH group. So to prepare this, if I will take N molecule of ethylene glycol and I will react with N molecule of terephthalic acid. So what will happen when these two molecules combine? There is a removal of water molecule. So water molecule is removed. So this is coming under the category of what? Since the one small molecule is removed, this is coming under the category of condensation polymerization. Okay, when this, so in this reaction, alcoholic OH group, in this reaction alcoholic OH group in the ethylene molecule, this is the ethylene molecule and this is the alcoholic OH group of this ethylene molecule, condense with what? Carboxylic. This is the carboxylic group of hydrogen atom. So OH group of ethylene group and H of the carboxylic group, when they combine, they remove the water molecule by the elimination of water molecule, and this result in the formation of, see here H on this OH is also removed. So what will be there? O dash, see here, O dash CS2 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 CS2. This is removed, this blue part is removed, then dash O CO C double bond O. CO is C double bond O, and benzene ring and C double bond O. So this is the repeating, this is known as stearinine dacron. So ester group, C double bond O carbon group. Therefore this is the since this is a ester functional group, therefore it is known as, since many ester molecule are formed, therefore this is a ester linkage, so this is called as a polyester. Therefore it is a forming ester linkage. So whenever there is a elimination of water molecule, there is a formation of ester linkage in this. Next is ring opening polymerization. Ring opening polymerization is about addition of the single monomer unit to growing molecule. So ring means what? Circular shape. So what we are doing is, there is a monomer which is used, is a ring type. This is the starting material for the preparation of nylon 6. To prepare nylon 6, we require a ring type monomer which is known as epsilon caprolactam. The formula is NH-CS2 C double bond O. So in this what happened, there is a breaking of bond between C double bond O and NH. So when it breaks in the presence of water and 533 to 543 Kelvin, to gives a, see here NH, see here, NH is there, CS2 1 2 3 4 5 CS2 is there, CS2 whole raised to 5 dash C double bond O. This is the repeating unit. Why it is called as nylon 6? Because the starting material which is used contains 6 carbon atom, 1 2 3 4 5 6. Therefore it is called as nylon 6. And why it is called as a polyamide? Because after this C double bond O, then the next molecule will have a NH group. So C double bond NH is the amide group. Therefore this many amide group is formed. Therefore it is called as polyamide polymer. So during the polymerization of this cyclic ring opening, there is a cyclic compound like, so here the cyclic compound used is what? Epsilon caprolactam. The lactam is there. Similar to this ether, lactones, so all are ring compound. When they get polymerized, the ring get opened of this by using some acid and water or base something. Here water we have used, you can use acid and base, and the reaction will get faster and you will get a product. The ring straight chain, linear chain polymer you will going to get. So here the example is epsilon caprolactam. From epsilon caprolactam we have prepared nylon 6.